Hey, welcome to The Explainer. Today, we're going to pull back the curtain on how machines actually learn. It can seem like total magic, but behind pretty much every AI, it all boils down to one of just four big, brilliant ideas. So, let's break them down. So, here's the fundamental question, right? How in the world do you teach a pile of silicon and circuits to recognize a cat, or drive a car, or, I don't know, write a poem? It's a massive challenge. Where do you even start? Well, believe it or not, the best way to wrap your head around this is to imagine you're building some IKEA furniture. Seriously. This simple analogy is going to be our guide through this whole thing. Just think about it. If you have all the parts and a perfect manual, you'd work one way. If you just have a pile of parts, you'd work another way. Machine learning is, well, it's pretty much exactly the same. All right, so let's start with the most straightforward approach. This is like opening that IKEA box and finding the perfect step-by-step instruction manual sitting right on top. Phew! This first idea, it's called supervised learning. And the supervision part, well, that comes from us. We humans give the machine a gigantic data set where every single thing is already labeled. We feed it thousands of pictures of cats that are all labeled cat, and thousands of pictures of koalas, all labeled koala. We're basically giving it the answer key up front so it can figure out the rules for itself. Now, with that answer key, you can pretty much do two main things. First up is classification. That's all about sorting things into different buckets. Like you see here, is it a cat or is it a koala? And the second one is regression, which is all about predicting a specific number. Not just if a house is going to sell, but for exactly how much. And this stuff is happening all around you every single day. That spam filter that keeps your inbox clean, the Zillow estimate on a house, even your phone's photo app that automatically knows which pictures have your dog in them. Yep, that's all supervised learning. It's incredibly powerful as long as you've got that good, clean, labeled data to kick things off. Okay, but what happens when you lose the instruction manual? What if you open that box and all you find is a giant, chaotic pile of unlabeled parts? Well, that brings us to our second big idea. This is unsupervised learning. Here, we give the machine a ton of data, but this time there is zero labels, no answer key, no help. It's like we just dump the digital version of every IKEA screw, panel, and dowel on the floor and say, figure it out, find the structure in there. Its entire job is to find the hidden patterns all on its own. So how on earth does it do that? Well, it mainly does three things. First is clustering, which is just grouping similar things together. Think of it like finding natural groups in your customer base. Then there's association, where it finds these weird hidden relationships. The classic story about a store finding out that people who buy diapers are also very likely to buy applesauce. And finally, there's dimensionality reduction, which is just a fancy way of saying it simplifies super complex data so we can actually understand it. And the real-world impact here is huge. It's the engine behind Amazon's customers who bought this also bought recommendations. It's how your bank spots fraud by seeing a transaction that doesn't fit into any of its normal clusters of activity. It's all about finding these powerful insights that we humans didn't even know we should be looking for. Okay, so we've got learning with an answer key and learning without an answer key. But what if there was a third, kind of sneaky and incredibly clever way that combines the best of both? This is where modern AI gets really interesting. Just ask yourself this question. What if, instead of needing a person to write the manual or trying to build with no manual at all, what if the AI could just look at that giant pile of parts and create its own set of instructions? And that, right there, is the magic of self-supervised learning. The AI takes a huge amount of unlabeled data, let's say a sentence, and then it creates a puzzle for itself. It might hide one of the words and then try to predict what that missing word is based on all the other words around it. By doing this millions and millions of times, it basically teaches itself the rules of language. It creates its own answer key, and it can generate almost limitless training data without any human help. This table here makes the difference crystal clear. You can see supervised learning needs that fully labeled data, which means high human effort, and its goal is prediction. Unsupervised learning uses unlabeled data to find patterns. But look at self-supervised learning. It also uses unlabeled data, so human effort is low, but its goal is totally different. It wants to learn a deep representation of the data by solving its own puzzles. And the payoff for that is just massive. And here is the absolute kicker. This technique is the engine that powers the incredible large language models we're all talking about today. Models like GPT from OpenAI or Google's BERT. They were all trained using self-supervised learning on pretty much the entire unlabeled text of the internet. All right, we have one final and very different way of learning to cover. This one isn't about looking at data patterns. Nope. This one is all about action, consequences, and rewards. Welcome to the world of reinforcement learning. Just imagine an AI agent playing a video game for the very first time. It has no idea what to do. It doesn't have a manual. Instead, it just starts doing stuff. And when it takes an action that gets it closer to a goal, like grabbing a coin, it gets a reward, a point. But when it makes a mistake, like running into a wall, it gets a penalty. It all works through this simple but incredibly powerful feedback loop. The agent tries something, it sees what happens, and then it updates its internal strategy to try and get more of those rewards and fewer of those penalties next time. You let it do this millions of times, and eventually, it develops a really sophisticated strategy to win the game. And this kind of learning is absolutely essential for any problem that involves making a whole sequence of decisions to reach some kind of long-term goal. It's how we teach robots to walk or assemble things. It's how self-driving cars learn the best way to handle a tricky intersection. And it's how complex logistics systems can figure out how to manage a warehouse for maximum efficiency. So we've covered 4 totally distinct ways to teach a machine. And that leads to the big question, right? Which one is the best? Which one wins?
Well, the answer, of course, is that there is no single winner. They're just different tools for different jobs. Think of this final slide as your ultimate cheat sheet. If you have labeled data and you need to predict something, you use supervised. If you want to find hidden structures in your raw data, go with unsupervised. If you want to train a massive model like ChatGPT, that's a job for self-supervised. And to teach an agent how to master a task through trial and error, you need reinforcement learning.
And that brings us to our final thought for the day. The trend is clearly moving away from methods that need a ton of human effort and towards these methods where the AI can learn more and more on its own. So as these systems get better and better at teaching themselves, we're left with a really fascinating question. What is the next human task it will master? What's the next frontier?